So we're going to determine the area bounded by these two polar graphs. Um, so it's the area that's inside both of them. That would mean we're looking for this area right here. So first we have to identify the graphs. R equals 2 just means the radius is always 2, which means it's a circle with radius 2. So that makes sense that that's a blue graph. This other graph is a red graph. So when we start the area, if I draw my radial lines, it looks like some of the key spot would be here and here. So the circle, its area would be the integral from here to here. And then the other graph is bounded by the integral from here to here. So the big thing is to figure out what these angles are. And it looks like, and this is how, it looks like it should be around, that might be 7 pi over 6. This might be 11 pi over 6. But you don't want to just guess. So let's find out where these intersect. So set them equal to each other, as always. We're going to get 2 sine of theta equals -1, or sine theta equals -1/2. So the two angles would be theta equals, well, there's a lot of solutions, but we could go negative pi over 6 for the first one, right here, and then to 7 pi over 6 for the second one. So here we go. If I want to get, so I'm going to break this up here. You could actually use the area of a circle to get the circle and just use a percentage of it, but I'm going to do it with the integral. So I'm looking at that area, the yellow area plus this light blue area. So let's do the yellow first. We're going to integrate this R graph, which is just 2. By the way, the integral of, when you're dealing with polar graphs, is just this. So we have 1/2 2 squared d theta. But we're going, remember here, from negative pi over 6 to 7 pi over 6. And then we're going to add to it from here to here. So I'm just going to keep going with this. I'm going to say, hold on a second. And you can change up the limits as long as you're in the right, as long as it works out right. But I'm just going to keep going. I'm going to go from 7 pi over 6 to, this would be 11 pi over 6. Of r squared, which is 3 plus 2 sine theta squared. So that's a little messy, but this is just r squared here. 1/2 would be multiplied by the whole thing. The first integral is just 4 times the length of this interval, which is 8 pi over 6. So 1/2 times 4 times 8 pi over 6, which is 4 pi over 3. This next integral, we're going to grab the calculator. I'm I'm not going to create a Word document. I'm going to grab the calculator. So we have 3 plus 2 sine theta. That whole thing squared. And we're going to evaluate that from 7 pi over 6 to 11 pi over 6. So integrate from 7 pi over 6 to 11 pi over 6. And we get 3.9857. Remember, this 1/2 is multiplied by the whole thing. So I'm just going to calculate that now. I'm going to add 16 pi over 3, and I'm going to divide it by 2. So I'm going to add 16 pi over 3. And then finally, I'm going to divide that answer by 2, or multiply by 1/2. And we get 10.370 is the area. So there you go. The key to these areas, these polar areas, is knowing and being able to determine where everything's starting and ending as far as the radial lines go, as you can see. So have fun with those.